Right. In the previous video, we went over this relationship, and there's a special name for this one, and that is called the power series representation of this function, right? Remember, this is just a function on the real number set, right? Except 1. So what we have done is we have represented the function as a power series, but that representation is only valid within the interval of convergence of the power series, right? Okay, now let's see whether we can use this relationship to obtain power series representations of some other functions. Say, for example, if we take this function 1 over 1 plus x squared, how about this? Can we write down a power series representation for this function? Of course, we can do that, right? So how are we going to do it? We can directly relate this equation to obtain the power series representation of this one, right? So for that, what we can do is we can take this 1 over 1 minus x term, right? 1 over 1 minus x term, and that was equal to this one. So that means if it is within x minus, within this region, whatever the value we choose here, you will get this series representation. So what we are going to do is, instead of this x, we will write x squared, right? So instead of this x, you will get an x squared term, and that will be raised to power n. Okay, so originally we had 1 minus something, and that was equal to this term raised to power n, and this term should be that term, the modulus of this term should be less than 1. So inside this term I am writing x squared. So here you will get x squared, here you will get x squared, right? Then what we have is 1 minus x squared is equal to the sigma x squared to the power n. But still this is not the function that we need, right? We need 1 over 1 plus x squared. So what we can do is, instead of this just substitute or just replacing it with this x term with x squared, what we can do is we can replace it with negative x squared. So here you will get a negative term, and that along with this negative term will create a positive term. So here you will get negative, and here you will get negative, right? Then ultimately what you will have is something like this, and the negative in here will vanish. So you will get this one, and here you will have negative 1 to the power n x to the power 2n, right? And for this one you will get x squared less than 1, and that is the same as x, the modulus of x, less than 1. So ultimately we have a power series representation for this function. So this is how we extract out some power series representations for different functions out of this main equation, right? And in the next few videos also we will go over some more examples of this nature.